Good morning, my dear students. Tahir Irfan, A-level chemistry teacher from Roots International School, Sialkot. Again, with another video shot especially for A-level students to understand the reaction mechanisms. As we know, the reaction mechanism are very important to understand organic chemical reactions, and most of the exam questions are actually based upon these. Okay, first of all, the reaction that we need to understand is the free radical substitution mechanism. The free radical substitution mechanism. Now, what is this? Free radical substitution is a reaction mechanism in which a hydrogen atom in an organic molecule, for example alkane, is replaced or substituted by a halogen atom. So when we say halogen, we mostly mean chlorine and bromine. It can be iodine, but most commonly chlorine and bromine, through a free radical process. Now, what are free radicals? Basically, free radicals are atoms or group of atoms which have a single unpaired electron on them. For example, if I say Cl with a single dot, so this is a free radical. It means the atom of chlorine that contains one unpaired electron. Obviously, there are other electrons as well, but all those electrons are in pairs. So if we find an unpaired electron, we can say that this particular structure is called a free radical, and they are very reactive. So free radical substitution method, it is common in alkanes and follows a three-step mechanism. So we have allocated names to these steps. Initiation, there will be propagation and termination. So first start with the initiation. Now we must remember, initiation is the step from molecules to free radical. So we will start with molecules that doesn't contain any free radical, and it will be broken up into free radicals. As you can see over here in this chemical equation, you can see a chlorine molecule, that is Cl2. A chlorine molecule, it is split up into two atoms of chlorine, each containing one single unpaired electron. So these structures are actually called free radicals. So how it happens? Basically, the ultraviolet light, as I have written UV light, it is capable enough to break a chlorine molecule equally, that each chlorine atom gains one electron. So this type of breakage is called homolytic fission, as it is written here. Please remember, when we put hydrogen chloride in water and make aqueous solution, hydrogen and chlorine atoms again split up, but that is not homolytic fission. We know in the case of HCl, hydrogen is positively charged and chlorine is negatively charged ions. They will be freely moving in water. So that particular type of breakage is heterolytic fusion. So we will discuss inshallah in our another video. So far we confined ourselves to homolytic fission, in which a molecule is broken up into free radicals, as we can see over here. So the reaction begins with the formation of free radicals. Now these are free radicals. This typically occurs when a halogen molecule, for example chlorine or bromine, is exposed to UV light or heat, causing homolytic fission of the bond where covalent bond is broken equally. So this is the first step, As you can see, each chlorine atom gets one electron from the bond, forming two chlorine free radicals. So whenever you see a molecule changes into free radicals, we can say this is initiation step. Okay, let's move on to the next slide and let's see that in free radical substitution the second step is propagation. Now its hint to remember is there will be a free radical that will react with a molecule, and in the product there will again be a free radical and a molecule. So free radical plus molecule gives us free radical plus molecule, as you can see in this example. So one chlorine free radical, it reacts with a CH4 methane, it makes an HCl, that's a molecule, and again a CH3 free radical. So this is basically propagation, in which we have a free radical and a molecule, and it gives us again a free radical and a molecule. So let's read that the free radicals react with the alkane, generating new radicals and continuing the chain reaction. A chlorine radical abstract a hydrogen atom from the alkane. So one HCl will be formed and there will be a CH3 left that will contain a single unpaired electron on carbon atom. So this is called a methyl radical. So a methyl radical is formed, this one. The methyl radical reacts with another chlorine molecule. As you can see in this lower equation, there is a chlorine molecule over here, and the methyl radical, it reacts again making one molecule and one free radical. So this is also a propagation step. So there can be many propagation steps, but please remember the identification of the propagation step is free radical plus molecule, again free radical plus molecule. So a new chlorine radical is formed, continuing the chain reaction. So when this happens, if we mix chlorine and methane and provide ultraviolet light to them, there will be multiple chain reactions starting at the same time. Let's move on to the next slide. Now the last step of free radical substitution, termination. Termination means end. Now its identification is there must be two free radicals, they will join with each other to make a molecule, and the reaction will stop for them. So two radicals combine, stopping the reaction. Possible termination steps include, there can be many, so I have selected a few one. For example, if two free radicals of chlorine atoms, if they combine, they will make a chlorine molecule. Now if a CH3 free radical that I told you, methyl radical, it combines with the chlorine free radical, so there will be CH3Cl, monochloromethane, because it contains one chlorine atom, monochloromethane. Now if two methyl radicals, they combine with each other, so they can make an ethane molecule. So it means there is no hard and fast rule in termination. Just what we need to remember is that in termination there must be two free radicals combining to make a molecule. So further substitution can occur, forming dichloromethane, trichloromethane, tetrachloromethane, and even you can see ethane can be formed. Even the chlorine substitution of ethane can also be formed. So it means free radical substitution method is not a very precise method. it can make multiple products, many types of alkyl halides, and even longer chain alkanes. So my dear students, this is the one of the very important uh, mechanism reaction that is called free radical substitution. It takes place in 3 steps: initiation, propagation and termination. Thank you very much.